which we had yesterday. So as one of you just talked about it, the assignment was the roly-poly toy which you made yesterday. You were supposed to identify what all can be changed, what all are the variables. Also, you were supposed to classify the variables into independent, dependent, these two categories, and also predict that if you change any one of these independent variables, what will be the effect? What will be the effect on the dependent variables? Just to recap, what are independent and dependent variables and what are variables? So in any system, there are some things which can be changed and some things which cannot be changed. What can be changed are variables, what cannot be changed are constants. The variables, further, you have some, if you change those, there will be an effect on other variables. So the ones which we change to observe the effect on other, they are called independent because they don't depend on anything else. But the ones which get affected as we change the independent variables, they are called dependent because they depend on these variables. So you were also supposed to find out which of these are dependent and which are independent. For example, some of you have said, let's say, the color of the ball. And while the color of the ball is definitely a variable, so I'm sharing the spreadsheet where we have got the homework. So as you can see, we have a total of 25, actually 24 submissions. And the first thing I would like to acknowledge is, irrespective of what you have filled in the homework, the very fact that you have attempted is valuable for you because you have gone through that thinking process. So even for future, I would request that please don't miss the assignments. So for example, the very first submission here, there are two independent variables which Sohni has identified: the size of the ball and the color of the paper or ball. It's important to think that if I change the color, let's say instead of orange colored ball, I have a blue colored ball, or instead of a blue colored paper, I have a white colored paper. What difference will it make? What will be the effect? And the moment you identify an independent variable and think of what are the dependent variables which will change, you'll realize that certain variables are not as important or related to the study that we want to do here. What is the study? We want to understand as we change, is there an effect on the behavior, the functioning of the roly-poly toy? So here the functioning itself will not change. Of course, the looks wise, if I take two contrasting colors, my toy will look better. So the dependent variable then is the looks, how beautiful the toy looks. But the functionality itself, there's no change. And hence, considering, let's say, the color of the paper or the ball as an independent variable is not a useful investment of our time if we want to do a scientific study of the functionality, how the model is behaving. Let's focus on the other variable which is commonly identified. Many of you have talked about it, which is the size of the ball. So if I take a bigger ball, what will be the effect? But what will I observe? I can change many things, but what am I going to observe? So in this case, Darsh has said he will change the size of the ball and observe the quantity of the sand. Give me a response. Does this make sense that I change the size of the ball and based on that, I observe how much sand I'm going to put? And let's say I collect data, what will I infer from it? So you can unmute yourself and give your response. Ashay, I'm assuming children are able to unmute themselves. If not, please give that permission so that they can respond.
Okay, Vishal.
Aditya has raised hand. Aditya, go ahead and unmute yourself and share.
Yes, sir. So one thing which I wanted to tell is that Darsh has written the size of the wall, it is an independent variable, whereas the quantity of the sand is dependent. So the larger the size of the wall, the more the sand is needed. But
Yes.
I have written the quantity of soil or the amount of sand taken is also a variable, because if we take more soil, the toy may not balance properly. But if we take like, it depends, like it needs to be an exact amount. If we take very less soil, the toy will again not balance.
Yeah.
So the soil can also be an independent variable.
Yeah. And that's the reason this is a very interesting case. So what I hear, Aditya, is that you are saying that you agree with Darsh that you increase the size of the ball, then the quantity of sand will increase if you want to, let's say, maintain the same level inside the ball, right?
Yes.
But quantity of sand can also be treated as an independent variable. That, let's say, I keep the size of the ball same but increase the quantity of sand, then what is the impact on the balance? And what you are also saying by saying that, Aditya, is that the balance, the extent to which the toy balances, that is what you will observe, and hence that is your dependent variable.
Yes.
Okay, thanks, Aditya. Thanks for sharing your thought. Let me
Yes.
hear from some of the other children. Uh, I can see, maybe Ashay, you have a better view. Why don't you moderate that? Who should unmute next and speak?
Aditya Sharma, you've raised your hand.
He just spoke, so maybe the next child.
Vedansh Khanna.
Okay, sir. Sir, actually, I just wanted to ask a thing, sir, because I have just joined. There was an error at my place. So, sir, can you just tell that what are you doing? There was a network error at my place.
Yeah, what we are doing is we are discussing. So yesterday's assignment, 24 children have submitted the assignment, and we are looking at some of them so
Okay,
as to
sir.
understand. Yeah. So if you
Okay,
have
sir.
a thought on, and specifically the question was size of the ball, if we treat that as an independent variable, one of the submissions says that I will treat the quantity of sand as a dependent variable. And does that make sense to you? What will you observe by doing this?
Please repeat the question.
So the question is, one submission, as you can see here in the shared screen, independent variable is the size of the ball. So let's say I can increase the size of the ball, and dependent variable, which I'm going to observe as I do that, is the quantity of the sand. So what you can do, Vedansh, is you can go back on mute, think about this, and if you have a response, you can come back.
Okay, sir.
Do we have Darsh?
Madhura,
I want to hear if Darsh himself is there. I would
Sir,
like to
I'm
hear
here.
his thought. Yeah, please go ahead, Vita. I want to hear what was your thinking.
So in the video, it said that the ball should be of the sand inside the ball should be 1/4. So I thought if we change the size of the ball, then we might also have to change the quantity of the sand to meet the 1/4 of the ball.
Completely agree. The question I have is, let's say now you actually implement, you conduct this investigation. So you increase the size of the ball. So initially you started with a say 7 centimeter diameter ball. Now you make it a 14 centimeter diameter ball, and you also observe how much is the quantity of sand, so that 1/4 of the volume gets filled, 1/4 of the hemisphere. What will you infer? Based on this investigation, what will you infer about the functioning of the roly-poly toy?
It will balance, I think so.
And the balance will be same as before, big ball as well as small ball.
I think so.
Okay. And since you are saying it will balance, what are you actually observing? What is your dependent variable?
My dependent variable is the quantity of the sand.
Okay. So let's say the quantity of sand has increased as you increase the size of the ball. What will you infer from that?
I don't understand what you mean.
What I mean is, The reason we identify independent and dependent variables is to do the experiment and conclude something. And what you are saying is you'll increase the size of the ball and observe how well it is balancing. So how is the quantity of sand a dependent variable? Because you are not observing that, you are observing how well it is balancing. The quantity of sand will increase, but that's given since the size of the ball is increasing. Okay, we can move to another submission, but before we do that, I see that Madhura wanted to say something. Shri Krishna, will hear your thought for the next sample.
Sir, can I talk?
No, I want Madhura to share.
Okay, sir.
So by increasing the diameter or the size of the ball, as Darsh told, you also need to increase the amount of sand because they have told that you need to put 1/4 of each hemisphere. But in case you don't put 1/4 of each hemisphere, you make it more or you make it less. The heavier the weight, probably the center of gravity is more, so it won't roll a lot. It won't roll much. But if the weight is less, since there's not much gravity, it will roll more, and that also affects the wetness of the sand, because if there's not much wetness and there's less sand, it won't even stay for a little time when you keep it stagnant. It always keeps on moving. That's what
Yeah.
we wanted to do.
So instead of sand, if we had a liquid, how would it behave? That's something that I would like.
Liquid does
you
not stay stagnant, so it keeps on
So
moving.
will it come back? Will the behavior be
No,
same or different?
It won't come back to the middle and pass. It just keep on doing the same thing.
Okay, you should implement it and try out, test it. Okay, so let's look at another submission. So here someone has identified position of sand, weight of sand, thickness of the paper, size of the ball, and amount of sand. So lots of independent variables, and dependent ones are rolling time and stable position of the toy. So stability itself.
Sir.
Yes.
Yes, sir. I thought about the second one because when I heard you that you were taking the last one, Madhura as the last one for the previous one. So, sir, I thought about this next submission. So, sir, I want to speak about this.
Okay. Just hold, Vedansh.
Okay,
Shri
sir.
Krishna has also raised hand, so we'll go in sequence. Yeah. But before Shri Krishna, let me see if we have Advik himself. I want to hear from Advik what was in his mind.
Yes, sir. Good morning, sir.
Good morning, Advik. I wanted to know what were you thinking? How will you find the stable position? So how exactly will you find the rolling time and stable position of the toy?
Sir, the rolling time is affected by the weight of the sand and the position. The weight of the sand affects the rolling time. So if we have a heavier sand, then it will it will become stable quicker than when the sand is light. And so by stable position, I mean when it has rolled. So is it slanting, erect, or is it lying down? So that will be affected by the thickness of the paper and the position of the sand.
Okay, so I think I understand what you mean by stable position. You are saying after it has finished the rolling and stopped, is it standing straight or
Yes,
is it
sir.
slanted?
Yes, sir.
Okay.
Sir, I have a doubt.
Just 1 minute.
Okay,
Rolling time, what do you mean by that? Are you referring to the number of times the toy will go back and forth?
Yes, sir.
Okay.
Sir, I had a doubt.
Go
So
ahead.
can there be a variable which is also an independent variable and also a dependent variable? So like the ball. So sir,
Yes.
we can change the size of the ball, which will so we will have to change the quantity of the ball, so that will be the size of the ball will be an independent variable there. But sir, when we change the length of the cone, so and basically the width of the cone, then we will have to change the size of the ball also. So sir, will that be an dependent variable on the same time?
Yes, that's an
Okay, sir.
excellent question, Mansima. And in fact, even the previous example, which where Darsh has said the quantity of sand, that's also, so that as well as the height of the cone, as you said, these are some of the variables which can be. So there are multiple independent variables, and hence also one variable you change, inadvertently you end up changing another variable. So let's say I want to increase only the quantity of sand and not the size of the ball. I can do that, but if I want to increase the size of the ball and not change the quantity of sand, then the level of sand inside the ball, that changes, even if I don't want to. And that is why I suppose in the previous session, you have also been introduced to this thing called controlled variable. So in any system, you typically have more than one independent variable, and there are some independent variables which depend on each other. And it's important that we control other variables. And that is one of the toughest things to do in any scientific inquiry, which is the reason we sometimes feel that laboratories are necessary, because in laboratories you'll have instruments to control other variables. It is same thing as if you enter a dark room and there are 10 switches, you want to find out which switch belongs to the light. So if I switch on 3 switches and the light is switched on, I can't make out which switch is switching on, which out of those 3. That's the reason at a time only one switch should be on, remaining 9 should be off. Only then I can exactly say that this switch is making the light on. Hence, independent variables also, at a time you change only one independent variable. All the other independent variables are supposed to be controlled. And if that's not possible, then your scientific inquiry, scientific investigation is not accurate. So in that sense, the 2 examples that we just looked at, the height of the cone as well as the amount of sand as we change the size of the ball, these are excellent examples of 2 control variables which are difficult to control, because even if you don't want, you'll have to change those. And hence size of the ball is not one of the best independent variables which we should consider here, because it will not give you meaningful results. Thanks for asking that question, Peter. Shri Krishna, I think you have been waiting. Then I would like to hear from Vedansh.
Yes, sir. I have a doubt. Is dependent variables is mean by the result of experiment?
Dependent variables. So when I change the dependents get affected. So quite often it's the result of the experiment, because changing the independent variable is your experiment.
Okay, sir.
So in that sense, what you are saying is correct, is accurate, but it's just that sometimes the obvious result is not what you want to observe. You may want to observe something else, and hence the dependent variables is also a choice that the person who is doing the experiment is making.
Okay, sir. Now I understood, sir. Thank you, sir.
Yeah, Vedansh?
Yes, sir. Sir, actually, I agree with Advik, as he said that the weight of sand depends on the rolling tide, and actually all of them. So first, let's go on the position of the sand. So, like, if I would put the sand on one side, it will roll smoothly at first, but when it reaches, when the area where the sand is reaches the bottom, it will become a little slow because of the weight getting, and then it would be going on the same speed, and then slowly, but it would stop. If the weight of the span would be great, the same thing would happen. The rolling time would take not longer but shorter, and it would be a little bit slower. the thickness of the paper, so that can also. So actually, in that I have a doubt that what like does he mean by this, the thickness of the paper?
So there are let's if you take newspaper, that's
Yes,
very
sir.
thin, right? And
Hmm.
usually you specify the thickness of a paper in terms of how many grams of paper you have in 1 square meter, which is also called GSM. So you get these 50 GSM, 75 GSM, 100 GSM papers. The standard A4 papers, the bond papers as we call it sometimes, which are used for taking printouts, they are usually the 75 GSM paper. So let's say from 75, I make it 150 GSM, and 150 GSM is typically those printed photographs that we used to get, or sometimes some of the cover pages of the books. They are close to 150 or
Kind of
200
like
GSM.
the weight of the paper, like how much grams it is.
Yes, so that
So, sir,
weight will also imply the thickness. Yeah.
yes. So the thickness will also take the rolling time, but the size of the ball
Mhm.
in this it might not take the rolling time, because it doesn't matter how much size it is, because it matters how much weight it is. So we can
Mhm.
say that the stable position. So like example, like I have this mouse. If I keep it here, it will not move at all. But if I would keep a ball, example, this is a ball, and if I keep it, it will stay at one position. If I keep it tightly. So what when I take a bigger ball, the center on where the center of the mouse where it's coming here, it would come at a different position, because that would just change the size, and in order to change the center of that.
Mm, 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 mm. Yeah, yeah. So I don't think the size of the ball won't affect. It will have an effect, and it could be a choice that we may not want to explore uh, the effect of the size of the ball. That is okay, but I think that it will have an effect. Similarly, the thickness of the paper. So if you think about it, uh, the whole system has a mass. So the ball as well as cone on top. So if you increase the thickness of the paper, the mass of the cone is also increasing, and that will have an effect on the stability. It is same as a person, let's say with broad shoulders. So versus someone who has a very thin kind of skeleton. If the height is same, mass is same, still their stability will be different, because one person will have more mass towards the top, whereas the other person who is thinner will have less mass, and which is also called the center of gravity or center of mass. So you would have noticed that in sports like cricket, etc., it's common to have tall players, especially the pace bowlers, etc., because they are able to throw the ball from a good height and hence get a good bounce. But in football, the short players, they are more effective because they have to run so fast, and as they do that, they don't topple as easily. But a tall football player may topple a lot easier. The Ferrari car is so much shorter than the regular cars that we drive on the road, because it has to move at such a high speed, and it shouldn't topple when it moves at a high speed. And hence, as you vary the thickness of the paper, the cone, you are shifting the center of mass further upwards.
Yes, sir. So the last thing, I think the amount of the sand, I think depends on is independent one, but weight of the sand and amount of the sand, like the weight of the sand depends on the amount. So the when I saw the amount of the sand, I realized that the weight would be like the weight of sand has to be like, if I have half a spoon of sand and I have two spoons and I have half spoon filled with sand. So the weight will be same. But if the amount will be greater, so that depends, so the weight depends on the amount.
So that's that brings to an interesting point, that let's say I take 1 teaspoon, or even better would be if I have a, let's say, a bottle cap, I fill it up to the brim with sand, and I take two different sources of sand. Will both of them is it guaranteed that both of them will have the same weight? If we want to use the term weight, more accurate would be to say that, is it guaranteed that both of them have the same mass if the quantity is same? Any thoughts on this? And you can, I know that we are able to have only few children unmute and speak, but you can continue to type on the chat window.
Okay.
So the question, let me repeat the question. Let's say I take the same quantity of sand, 1 teaspoon, or say a bottle cap filled up to the brim, but the sources of sand are different. One sand, say I've collected from a beach on the east coast, let's say from Chennai or Mahabalipuram, and another sand I've collected from, let's say, Mumbai, the one of the Mumbai beaches. Is it guaranteed that if I measure the mass of these two quantities of sand, it will be same?
Sir, I think it's no.
Okay, and say
Sir,
more. Why do you think it is not same?
Because means it is from a totally different part. We have some more distance for east coast to the west coast, and in many ways we are different from the eastern parts, and means there itself it will be some we can't express it.
But what I've collected is still sand.
Yes, sir.
East coast or west coast, forget east coast, west coast. I'll go to California and one of the beaches, I'll collect from there. But what I'll collect is still sand. Then is it guaranteed that the mass is same? And you are saying mass won't be same. So is it guaranteed that the mass will be different?
Sir, I think from the east coast it would have some iron content.
Okay.
Sir, because we get a bit black one near chin, like those areas.
Okay, sure. Okay.
So
Let me hear from some other people.
Madhura and Vartika, both of y'all had raised your hand. Madhura, do you want to go first?
Okay. So, sir, since they both are sand and it's in the same quantity, I think the weight will be same. Unless and until if in one bottle cap there is water mixed with the sand or some other thing added to the sand, then the weight will differ. But as long as it is the plain sand in the same quantity, the weight should be same. So it is guaranteed to be same.
Exactly. Yeah. So again, if you look at this question from the point of view of variables, we are actually changing only one independent variable. So I'm still taking sand. The quantity of sand is same, just the location is different. But now the two locations, this can be, one can be east coast, west coast, one can be on the same beach. I can go closer to the sea and collect some sand, or I can go away from the sea. And in both cases, one case, as Madhura was saying, I may have more water content in the same quantity of sand. And would that have an effect on the mass of that sand? So there are 2-3 things getting changed there. One is the water itself will add to the mass of the sand, and other is the way it gets packed, right? The water will make it coagulate, and hence the packing density that will be better if it is wet sand. And hence the reason I thought of bringing this up is in the context of what Vedansh was saying, that if the quantity is same, then the weight will be same. But I wanted to draw your attention to the fact that it's important to pay attention to these details when you are conducting a scientific inquiry, because sometimes without our realization, we end up changing more than one variable. So ensuring that the quantity is same does not imply that the weight of the sand or the mass of the sand will be same. Instead of staying here and discussing this further, basic point I wanted to highlight is it's the density of the sand which will have an effect on the mass, and hence you can't go just by the volume. Let me move to the next point. So there was one very interesting independent variable identified here, that position of sand, which Vedansh also gave a little comment on, but let's pay attention to that, right? So let's say the starting position when you fill the toy. So instead of keeping the hemisphere of the ball stable and perfectly horizontal, let's say I keep it little tilted and then pack sand. So in which case, after I fix the cone, the starting position itself is slanted. In that case, once I disturb, will it come back to the slanted position or will it come back to a vertical position, which is also related to, I think Darsh or someone else had also identified Advik had identified the position, the stable position at the end. Let's take one more submission, discuss a little, and then we will look at the demonstration of actually changing some of the variables. Here it is amount of soil, weight of paper, weight of soil, amount of water, weight of ball. So weight of ball is another interesting one. So if you increase the weight of the cone, so let's say I take the same sized ball, but I take a thicker plastic, then the weight of the ball would also increase. So this is also an interesting observation, that it's not just the size, but you also look at the mass of the ball itself. Time taken to balance depends on the amount of soil taken, weight of soil, amount of water. So what, so let me see who has made the submission. This is Aditya. What Aditya has done is he has also written down some independent variables here, but very clearly what he's saying is the time taken to balance is one thing that he's going to observe. The second thing he is going to observe is the angle at which it is displaced. So you disturb its stability and make it roll. So that initial angle at which you disturb its position, that angle is the the extent to which it would go. So that's another thing that you would observe. This
Hello,
is
Vishal.
also something.
Yeah, I would like to continue with this one, the explanation of this.
So sorry, I didn't get. Please repeat that.
Can I just start with the explanation of dependent, independent here itself, so that they get clarity on this?
Because we already have the context set. Is that what you're saying?
Yes, yes.
Sure. Let me stop sharing the screen.
Yeah.
Before that, I just wanted to highlight. So this was another thing which we just discussed, that depending on whether it's dry or wet. And this is a place where I again want to say, I think I didn't see any of you as considering the filling of the ball also as an independent variable. So please try that out. Instead of sand, try filling it with some liquid and see the impact. And though you may have your prediction, please test it out. Madhura had a prediction that it won't work, but please see what happens.
Sir,
Yes.
in my childhood time, I have researched this one, sir. In chocolate box, that gems box, it is round, no. So I opened it and filled water 1/4, and when I rolled it, it is rolling and rolling. And if we blow, it is not rolling. If we move with the hand only, it is rolling.
Yeah. Yeah, and in fact, that gems box, if you have that, then making this roly-poly toy is also so much easier, right? You don't have to do any cutting. It comes with nice threads.
Yes.
And
Sir,
yeah,
I
then
also use the gems thing for roly poly.
okay.
Sir,
That
I
was a
also
very
use
smart idea.
the gems box for the roly poly toy.
No, that, that's interesting. So many of you thought of that. So the gems ball in particular, if you play around with it, uh, so what I have observed is it looks like a ball, but it's actually not a perfect sphere. It's skewed in one direction. And if you fill it with different objects, in fact, with the gems itself, when you get it from the shop, if you put it on the floor and give it a spin, you would observe a very peculiar kind of motion. Let's say compared to that, I take a regular tennis ball or a rubber ball and roll it, spin it. The type of rotation you'll see will be very different from the type of rotation you'll see with a ball which is filled with something solid at one end. And it would then be very interesting to fill it with water and repeat, see what happens. Try throwing it up and trying to catch, because when the way it comes down is very different from the regular ball.
Yes.
Yes, Shivani?
Yes. So I see like many of you have confusion regarding yes. So I see many of you have confusion in what is dependent, what is independent. So let me just make it easy. Let me make 3 columns. Is the screen shared? You guys see?
Yes, we see a whiteboard.
Yes. Okay. Who's that drawing?
Yeah, go ahead. I'll disable that. That's typically the case.
Okay. Now let's understand what is the difference between these three. Okay. So this was our roly poly. Okay. So now I'm just tilting it to only this much. Okay. So this was our mean position. This was the mean position. I'm just tilting it little. Okay. Notice how much time it takes for it to come back to its normal position. That is, it stops oscillating. Okay. I'm taking a little and it stops in few seconds. Tilting a little more. It's taking a little bit of more time. If I tilt it more, it's taking some more time, right? Okay, who erased that? I request
I
you
think you
guys
may
not
have
to
to.
write anything, please.
I'm
You may have to
unable to.
disable.
I'm trying to
Mhm.
find the settings for this, but I've never used this before. So I don't
Shivani,
know.
you'll find it yourself. So you can see disable annotate for the participants. And while Shivani does that, whoever is doing it, you have the option of leaving the session if you are not interested. But please don't do this, because you are also wasting not just wasting your time, but wasting other people's time as well.
Okay. So at first, what did we do? We took just the same roly poly, right? And what did we do? What did we do? We just changed the angle. Correct. So what was the independent variable here? What did we change? We changed the angle. Okay. So we changed the angle. And what did we observe? What we observed was the time taken for it to come back to its mean position, right? That is stop oscillating. That is what we saw. Okay. So that was dependent on it. Okay. So I changed the angle. Okay. So the time taken for it to stop oscillating is varying. Correct. So independent is the angle and the dependent is the time taken. Okay. So what am I controlling here? It's the same roly-poly. So the amount of sand is same. Okay. Amount of sand is same. The height of the top is same. Okay. And what else? The ball size is same. Okay. So did you get an idea what am I saying? What is independent, what is dependent, and what is controlled? Okay. So the controlled is one which you don't vary at all. Okay. So next, let's see, I'm taking and in this, what I'm taking is this was our original roly-poly, and now I'm just changing only the size of the ball. Okay. What am I changing? The size of the ball. Okay. I'm changing only the size of the ball. And I'm not changing anything. The peak is same. The amount of sand is same. Okay. Now see what happens. I'm trying to make it stand. It is falling. So what is dependent here? Center of gravity is changing, right? So in this, the center of gravity is at this point, okay, at the center. So that's why it's coming back to its mean position. Here it is getting shifted. Okay, so what did we see? Center of gravity is shifting. That is the dependent.
What's happening to the height of the cone, Shivani?
Yeah, I've kept it constant. I've kept it same. The height is same. I'm only changing the size of the ball. Amount of sand is also same inside. It's
The
not
level of
one
sand will
third.
change.
Yes,
The level
level
of
of
sand
sand
will
is more.
change.
Yes, yes. So it's not the one third of this ball. Okay, so the amount which I have added here, the same amount I'm adding it here. Okay. And what else have I controlled? The amount of sand is same. Amount of sand. Cone height. That is, I can say top. I'll call this top. Okay. Top height is same. Okay. And then, yes. So that was the thing. And we saw the center of gravity changed for this. Okay. Now what I'll do, I'll take the initial cone. And now this time I'll change the shape. Okay. Same amount of sand, same ball, but I'll change the shape. Okay. I'll try doing this on the surface if I can. Okay. What do you see? This stops oscillating in just few seconds. It doesn't take a lot of time. You can see that. Okay. So this time what I'm changing, the independent variable is shape of the cone. and what is dependent on it. You can say two things, the number of oscillation also, as well as the time taken for it to come back to its mean position. Okay, so let me write two things here. I would say first number of, is anyone doing something? Please don't write anything here. So number of oscillations. And what I'm keeping constant is the ball size, the sand, and the height. Okay, the height of both of them are same. What I'm changing is only and only the shape of the cone. So these are all controlled. Okay. Okay. So now for the same thing, that is the shape of the cone. This time taken. Okay, this time the time taken, as we saw, this come back to its mean position very early than this thing. So the reason is because I feel the reason is because there's air inside, right? So that is making it to oscillate less. And what I've kept constant is the same thing, that is the size of the ball, amount of sand, and the height. Okay. So next, what I can do is I can take two same balls, same amount of sand, but change the height. Okay. And I'll see how much time it takes to oscillate. You can try out this. Okay. So you find out what is the dependent here. Okay. Try to find out what is the dependent here. And in next case, what I'll do is I'll take two tops which having same height, same size. This time what I'll do is I'll add a mass here. Do you see that? I'm adding a mass at the top. The center of gravity is shifting. It has shifted. It has taken a new place there. Okay. So I hope you understand what is dependent, independent, and controlled. We are just changing one quantity and seeing what is getting dependent. What are the dependent? We have to control all other things. We have to change. We have to see what has been observed. If you change too many things at a time, then you will not come to a conclusion because of what it is happening. Okay. Yeah. So this was my model. And there's one more. I created a small one which could balance. That is, I filled only the 1/3 of this small ball. And the other one was the one had more sand in it. Okay. And one more thing I observed was if you change the ball, which is having a rough side, even this oscillate less. Okay. This will come back to its mean position very fast, okay, because the surface is rough. So you can take down many of these things, like consider many independent variables and try to find out the dependent ones. Okay, you can change instead of sand. If you put a dry sand, what you would see is it will not come back to its mean position. It will try to take up a new center of mass position. It would not come back. It will be slanted like this. If I slant it, it will come back to this position. The center of mass would have been shifted here and the new position would be like this. If I shift it here, the new position will be like this. So you can change the sand, you can put liquid instead of that, you can try out with foam balls, you can add a nut inside and see what happens. You can fix a nut, like glue a nut there at the center and see what happens. So you can try out many variations of this, okay? So I hope I made it clear. So let's try seeing some of the other activity. Yeah, now let's watch this activity. And I want you people to find out what is the independent, dependent, and controlled here. Okay, control variable. Is the screen shared? I hope it's shared. Okay. Yes, Mathura. You can unmute. Not able to. Ashray? Yeah, so the experiment which you saw was motion periodic, okay? So what do you think over here will be independent, dependent, and controlled? Yes, okay, yeah, you can speak. Yeah, you can unmute and speak, I guess. Are you able to?
No.
Okay, I see.
Now I can. I'm able to unmute now.
Ah, yeah.
So the things that you can change in this single experiment is the length of the thread,
Okay, let me write it down.
the length of the thread,
Okay.
and then the weight of the thing in the bottom that you need to pull and start. That keeps on oscillating.
Okay.
So the weight, the length,
Weight, length. Okay. And what
probably
will be
the thickness of the thread and the thickness of the magnet.
Thickness. Thickness of the magnet.
Yeah.
Will that be a weight?
That will also differ in weight.
The size of the magnet, because it will depend on the length of the thread then.
Okay.
And one more thing that you can change is from which angle you leave the thread.
Okay.
So those are the 4 things you can change that I can.
So can anyone guess what is that angle called?
Which angle?
Right angle.
Yes. What Madhura told, the change of angle. From its
Straight
center, we are
angle.
pulling it to a, okay, I'm sorry, yes. So from a center, we are extending it to a distance and then leaving, right? Does anyone know what is that called?
Oscillation.
Oscillation? Or is it called amplitude? So it's called amplitude, okay?
Amplitude.
Yes,
Is it altitude?
amplitude. Change the amplitude. You can say angle in simple words. Okay, what else can be changed?
Ma'am, is it altitude?
Amplitude.
Amplitude. I can't. Okay, now
We
change.
can change the mass of the magnet. Mass.
Yes, that's written here. Anything else? And what will be the dependent?
Ma'am, the time taken to like to stop moving.
I'm taking for oscillation.
Yes.
Numbers of oscillations and time taken to
Number of oscillation. Okay,
So
that is good.
get back to the same place.
Ma'am,
Yes.
the time taken from.
time taken to again stay steady.
Number of
That's
oscillation.
what time taken for oscillation.
Okay.
So ma'am, by probably changing the length of the thread, after the point you won't be able to change the amplitude a lot because it will go upward and upward. So you won't be able to change it much.
Okay, okay. Anything else you would observe?
Ma'am,
Yeah.
ma'am, is this
So what is
speed?
controlled? Yes, yes, yes.
Hey Krishna, speak.
Okay, ma'am. Is the speed takes a major role in this activity?
You say, what do you think?
I
do you
think
think?
yes.
Speed? So
I
should I
think
put it?
Ma'am, the speed is independent and the time taken depends on the speed.
Okay, so how will you change the speed of a pendulum? How
Ma'am,
shall I
if
change the
we,
speed?
ma'am, if we,
person will throw in if some a person will leave it in that place itself, and
If
other
we-
people will throw it like
A pendulum is suspended in a thread, right? How do you increase the speed of the pendulum?
ma'am, you have to like push it. You have to give it a
Yes,
push.
ma'am.
Okay, okay, interesting.
We can increase or decrease the length of the thread. Then also it
Yes.
affects the
Hey,
speed.
can you play
But you can change. Yeah, sure.
Ma'am, the force you apply in pulling the thread and leaving it, it depends on the speed. So the more the force is, the more the speed will be there. And
Okay,
the
let me
lesser
write
force
that.
you apply, the lesser
Speed.
the
And what do you want to
force
up?
turns is independent.
And what do you think is
dependent
dependent?
Ma'am, the
Independent
time taken. The time
Time.
taken.
I think, ma'am,
Okay.
independent should be force and dependent should be speed.
Okay.
Ma'am,
Pull
it's
it very
independent
closely.
variables.
Okay, let me play that video again. Okay.
As sir had told, like independent variables can also be dependent on other independent variables.
So how can you do that? If you're fixing one value, then only you would be able to notice the other values, right? How can you change this also and notice changes in itself? Have you ever thought that? You're just fixing one value. Okay, you're fixing one thing and you're changing only this thing. Will you notice the change on this thing itself? It doesn't make sense. Can you imagine that?
It changes. It makes an effect on the whole. I mean, the whole project, the whole experiment.
Okay. Before starting the video, you guys did not say me what is the control here. If I change the length, okay, if I'm only changing the length, What is
And the
controlled here?
controlled is the place from where the thread is being released.
Okay, yes, very good. Amplitude. Amplitude is fixed. What else?
Ma'am, the surface.
I'm just changing the length. Okay, nothing
And
else
the
is
length
changed.
of the thread.
That is what is independent here. I'm changing the length of the thread. Okay,
Ma'am,
and I'm not.
Ma'am, the surface for the table.
Surface of the table.
Yes,
Okay,
ma'am.
just exclude that quantity. Don't include all the environment. Just only observe what is happening in the pendulum. Okay, so what else we keep constant? The mass. If we are changing the length, amplitude is
Mass
fixed.
constant.
Mass, correct?
But
Mass.
if you keep the mass constant, you can, or if you keep the length constant, you can change the mass.
Yes,
You can
correct.
both ways.
Yes, yes. So for changing the length, I can keep the amplitude constant, mass constant, and shall I fix the number of oscillation?
No, the
Can I-
more, like one time you might apply more force, the other time the force you apply might be less.
Okay, I'll apply equal amount of force. Okay, I'll apply equal amount of force. Okay, the force is constant.
But then it depends on from where you leave the thread.
Amplitude. That is amplitude.
Yeah, so if the
Okay.
amplitude and the force is same, then probably it will be the same time.
Okay. So actually, if you fix the number of oscillation, then only you can observe the time taken, right? If I'm taking only this much thread and I'm fixing the amplitude and leaving, I'm counting how much time it takes for 10 oscillation. I'm increasing the length. Okay, I'm fixing the amplitude. I'm leaving it. Okay, I'm fixing the number of oscillations to be 10. After 10 for 10 oscillation, how much time it is taking? Okay, so I'm only saying what is dependent here. Okay, so what is the quantity dependent here? Is the time taken. I'm fixing all other things and I'm changing one variable, that is the length. So that I come to a conclusion that, okay, I changed the length, that is why the time is taking so much. Okay, I cannot be changing the amplitude along with the, amplitude, mass, and I come to a conclusion, yes, the oscillation is more, the time taken was more. But I cannot justify because of what it was more. Was it because of the mass? Was it because of the amplitude? But here I'm fixing it, right? The length is fixed here. So I can come to a conclusion like, yes, I changed the length. That's why this number of time taken for oscillation was more. Okay, so that's why we are controlling these things. Okay, so same with weight. So with weight, what will be the controlled variable? I'm changing only the mass of the suspended magnet. Okay, I'm changing the magnet. What else will be fixed? Okay, I'm taking in consideration how much time it is taking for the oscillation. Okay, I'm changing the weight and seeing how much time it is taking for oscillation. Okay, someone wants to watch the video again. Now this was the one which you guys said, changing the amplitude. Okay. Okay. I just don't want to show it further. So you might get ideas. Yes. Yes. Who wanted the whiteboard back? Madhura. Yes.
I just
Yes,
wanted to
Madhu.
look at it. I
Yes.
to note it down. That's all I asked.
Okay. Yes. So this was, can anyone say only for the weight? What else can be independent?
Ma'am, the object used to like the magnet, ma'am, it can be replaced by any other object also.
Yes, correct. You can change the material. Okay. So for each case, just make sure if you're changing the weight, you are keeping the other things constant. Like if you're changing the weight and you want to note down how much time it is taking for it to oscillate, then keep all other things constant. Like keep the mass constant, keep the amplitude constant, and keep the number of oscillation constant. Okay. And for the other things as well. Okay. Yeah. So is anyone noting down? Yes, if you're changing the material, make sure that you are keeping the length and the mass constant, okay?
Ma'am?
Yeah. Yes. Was
Ma'am,
that?
changing the length of the thread.
Yes, that is there, right? First one is length of the thread. Okay.
The thickness
Okay,
of the
okay.
thread can also be changed.
Yes, you can try out many variation. Okay, now let me jump on to the second activity. So, okay, so since we are running out of time. Okay. So this experiment is DIY respirometer. Actually, you don't have to hear the sound. Okay, anyway, I'll just. Yes. Just give me a minute. Yes. So did anyone understand what was happening there? Okay, so here what is happening is we're taking lime water. Okay, that is that the pan you get, no, they put it in pan. So that thing they're adding in water and they're mixing it, they're filtrating, they're taking 5 ml of that solution and they're adding universal indicator, bromethyl, what was the name? The name is bromethymol blue, okay? Sorry for the pronunciation. So it's an universal indicator. And then what they're doing is they're blowing air in that, okay? So what they're doing is they're just exhaling carbon dioxide into that. So the indicator blue turns green, okay? So it means that it has taken up the carbon dioxide, okay? So it has formed calcium carbonate. So that is the experiment here. So any two, let's take any two examples, okay? Just say me what will be the independent. Okay, I'll just directly note down. Okay. Okay. So the name is bromethymol blue. Bromethymol blue. Okay. Name of the indicator. I guess you guys can unmute, right?
Yes, ma'am, we can.
We're able to unmute.
Yes, ma'am, we can unmute them.
Yes. So what can we keep the independent variable here?
We can
So
change
the-
materials.
Instead of using lime powder or tuna, we can change it to something else.
Amount of water.
Amount of water, okay.
Instead of
change of
lime,
color.
Change the color or change the material apart from tuna
Yes,
powder.
yes.
instead
Change
of the
material.
lime, instead of the lime powder, we can use sand. Like
Sand.
that.
Oh, okay, okay. Interesting.
Number of exhalations we made in within the
And ma'am,
Ma'am, the blowing time.
Blowing time. Okay. Okay. So is blowing time independent or dependent? What do you want to observe? So by changing the amount of water, what do you want to observe? What is the dependent here?
Much carbon
The
dioxide
color
is
change.
Color
The
change?
color change.
Okay.
The
And the
color
change of color.
Yes. Okay. By changing the material, we'll say the color change. Okay. The color change.
ma'am, what if you take a deep breath and blow through the straw? So
Yes.
the force in which you blow.
Yes. So here, force of blow.
Force of blow results in number of exhalations. If it is
Okay.
reduced,
Yes. So, okay.
Ma'am,
So you are saying this is independent?
which one, ma'am?
Number of blows or dependent?
Number of blow will be dependent if the
Okay.
force of blow becomes independent.
Force of blow, okay. Okay, so that was good. That was good.
if
So
we
now let
pour
yes,
water
yes.
in the filtration paper, that filter cup, it will take more time to come down.
Okay, so we are not focusing on that part here. The main experiment was we wanted the lime water. Okay. Yes.
Ma'am,
Yeah.
Ma'am, we should do this experiment in our home.
Yes, you can try out. You can try out.
Okay.
And we won't discuss today's assignment.
No.
There's no
So
assignment.
we'll be, you have an assignment. I'll say it at the end. Okay.
Okay.
There's no assignment.
Final activity here.
Ma'am, from this think tag, I see there are many videos. I've seen many of them and they are very interesting.
Okay. Is the video shared? I mean audio.
No audio wasn't shared. The
Okay,
video was being shared.
Now?
Yes, yes.
Okay. So did you guys see that?
Yes, ma'am. When they put
Yes.
pressure in the bottle, the water in the bottle filled up in the test tube and that the dropper. And when
Yes.
the dropper was filled like fully, it became very heavy and sank to the bottom. And when the pressure was stopped, all the water was sucked inside the bottle again. And the
Okay.
dropper became light with only 1 centimeter of water and it came up to the brim.
Oh,
Ma'am?
that was a good demonstration. Yes.
It's
Yes.
a pressure. It's a pressure experiment.
Yes. Yes. So what is so what do you think can be varied here? What is the independent?
Ma'am, in
And
You
the
guys
amount of
understand?
water, and the amount
Amount
in
of
the
water.
starting, instead of
Okay.
filling the
in both the dropper, in the dropper, the amount of water
The
getting.
amount of water in the dropper as well as the water bottle.
As
The
well
water
as the water
bottle, it
bottle.
has to be filled
So
to
is
the
this
brim.
independent or dependent?
Independent.
Dependent amount of water.
Independent.
Okay, just do one thing. Any one of you say me what should be independent here? What should be the dependent here? Anyone?
Ma'am, may I?
Okay, yes.
Ma'am, the amount of water should be independent and the dropper going up or down should be dependent.
Okay. Dropper
And the
going up and
pressure
down.
also, the pressure should be independent and the dropper going up or down should be dependent.
Dropper going up and down. So
Yeah.
dropper will go up and down, right?
Yeah, so that's dependent on the pressure applied.
Okay, is that the dropper going up and down or the pressure?
Pressure is at one place only, but the dropper is going up and down.
Is it? And how do you know that? That's why we have that meter over there, right? That graph sheet marked with 0, 1, 2, 3.
Yes,
Is
ma'am.
the pressure constant?
No, pressure is also not constant.
Yes. So what will you say for that?
Ma'am, like when we apply pressure, the water goes in the dropper and the dropper.
Water height, amount of water and water height. Can I say that?
Yes.
Water height in the dropper.
Yes.
Yes.
The size of plastic bottle also matters now.
Size of the plastic bottle. Okay. Size of plastic bottle.
And the number of magnet used.
Oh, okay.
But the water height in the dropper will change by the pressure. If you apply
Just
low
give me
pressure, then
one
the water
number
height
of
will.
magnets. Yes, number of magnets. Yes, yes. Who was saying that?
Mama Aditya, I'm saying that the water height will depend in the dropper, the water height will depend upon the pressure applied. If we apply low pressure, then low water height, high pressure, then high water height.
Yes, yes.
So pressure should be independent.
Pressure should be independent. Okay.
Because it's changing the dependent variable, which is water height in the dropper.
And then the height, right? Water height. Okay. So what else can I change? The number of magnets, that is the weight. And I can see if I add more magnets, what happens?
Ma'am, it may go down like less pressure applied and it goes down then only.
Okay.
It won't easily come up with the pressure. We have to apply more the pressure if it goes down and up.
So am I applying any pressure for it to come up?
No, you are
Did
just
you watch
releasing
that
the
video?
bottle.
I'll just play the last part.
I using pressure only to make that
Go
tube
ahead.
come down.
Yes,
Yeah,
yes.
to make it go down, to make it go make it come up, you just release the bottle
Hmm.
and
Okay,
it will
so
go up again. But it depends
don't
again
have
on
other
the
one.
magnet
Yes.
weight. It
Okay.
again depends on the magnet weight. The more the magnets, the more are the chances that it doesn't come up.
Come up. Okay, yes. Okay. Let's see what happens with that. That I can do here.
Because of the it is
So I'm
heavy.
having here one magnet. I'm taking one more magnet.
Can the temperature of the water means the water like it's hot or cold, ma'am? Will it affect the experiment?
That you can try out. Try out. That's very interesting. I like that point here. Temperature. Temperature of water. Okay.
Ma'am,
Yes.
ma'am, what is today's activity?
Okay, just give me a minute. Let me finish this first. Okay, I've added two magnets. Let's see what happens. I'm making it up to the level. Dropping it. It's sinking. Okay, so for that, what you need to do is add little by little, move it, and then you can try out. Okay, so how much amount of pressure you need to apply for it to go down and then come back. So can I change the nature of this medium?
I can't understand your question, ma'am.
So like, does it have to be water only? Can I change the nature? Like, can I use oil?
You can use oil.
Yes, I can try out with oil.
Ma'am, but it would be like very, oil is very dense.
Yes.
You can use oil. We can
I
change
can
it.
Ma'am,
change
but oil is
the.
like very sticky and it
Ma'am?
is hard to go through oil. Oil is the resistance.
Okay. Okay.
Ma'am,
Yes.
you can increase the quantity of water in the dropper.
Quantity of water. Yeah. Yes.
But
This
if we
was.
like make it from starting only, then it will sink.
Hmm.
If we increase the quantity.
Ma'am, you added the number of you added more magnets in the dropper. So ma'am, it just got synced. So ma'am, what will you do that it will come up again?
Yes. So it means that I can reduce the weight. Okay. I don't want it to come down. Okay. So I can add little by little more weight. Okay.
Ma'am, if we apply pressure to it, so ma'am, will it come up again?
You think it will come up? Let me try. Applying more
No,
pressure.
if we don't apply pressure, then it should
applying.
come up. If we apply pressure, then
It's
it will
not
go
coming
down. If we
Okay.
apply pressure, then it will go
Yes.
down.
So the mass of this thing is it has become so much that it has come down. Okay, we don't want that. Okay, so
It's
let's
heavier
try.
than-
Yes, it's heavier. Okay. So yeah, so that was today's experiment to make
Now,
sure.
what
like,
is this called?
So this is called as Cartesian diver.
What, ma'am?
Cartesian diver.
Okay.
Yes.
Ma'am, but the experiment said RYSI. I don't remember that.
No. So this was the
RYSI
experiment to.
Ma'am,
Yes,
and
sir.
the other three experiment was to show us the example, ma'am.
Yes, like what is dependent and independent variable here, okay? And what is controlled. So I hope you got an idea what is independent, dependent, and controlled variable here. So there's a small homework for you, as in it's a homework. Okay, so you need to shoot a 5 minutes video of, you can take in your own activity and try demonstrating this dependent, independent variable in that video. Is that clear?
Ma'am, on which activity?
You can choose your own. You can choose your own. Okay. It doesn't. It can be of your own. It's not anything specific.
We have to make that experiment and then we have to explain it.
Yes.
Ma'am, how long?
5 minutes.
Okay.
We have to find the independent, dependent, and the
Controlled. Yes.
Ma'am, where should we submit it?
Where can anyone? Yeah, Vishal.
Can you
So
please repeat what will be the content in the video?
Okay. So you should shoot a 5 minute video where you are you can explain how you made that, and you can vary few of the variables and show what you are what is independent.
And we have to
dependent.
note all the variables or only some?
Some is enough.
two variables. So change two
Independent and
independent
dependent
variables.
variables I need to say. And do
No.
I need to show that activity in the video, or just keep it aside and say about the independent and dependent variables?
No, you have to demonstrate. So you identify the variables, select two independent variables. Okay, one is not sufficient. Two independent variables, change them and show how that impacts the dependent variables that you have identified. So talking about variables is not useful. You actually show how the dependent variables get impacted because of that.
Ma'am, we should explain the dependent also.
Yeah, so you select the dependent variables and show the effect on the dependent variables. You have to demonstrate it the way Shivani demonstrated for the roly-poly toy. So she did not just say that you changed the shape. She actually changed the shape, had one cylinder and one cone, and showed how that is impacting, let's say, the number of oscillations it makes before it comes to a halt. So that you have to show in the 5 minute video.
So where should we share the video?
We will share the link on the WhatsApp group, just a short form. So you have to upload this on YouTube and insert the YouTube link in the Google form. We'll share the
No,
form
but I
on the
don't have
group.
a channel on YouTube.
You don't need to have a channel. If you have login to Google, then you should be able to upload it to YouTube.
Oh, okay.
We have to upload it in YouTube and share the fill it in the Google form.
Google form. That is right.
Yes, sir. Thank you.
So when will you share the link?
I will share one of us will share in the next 1 hour on the group. So if you are not
Sir,
on the WhatsApp group, please
where
join.
should we post? Where should we upload our video?
YouTube.
YouTube.
So in our YouTube channel.
Yeah, it can be your YouTube channel.
Sir, we have to create YouTube channel, huh?
Not needed. If you create a video, go to YouTube. After logging in, you should be able to upload. There's nothing more complicated than that. For if you participate in Raman Awards, you'll anyways have to do something similar. Anyways, this entire program is a preparation for that, so that if you practice, you can submit good quality innovations.
Okay, sir.
So in the competition, when will it be held?
It is on. So the stage 1 you can clear in one of the two ways. Either you get nominated by your school, or
I got nominated to stage 2.
Yes, then you can directly go to stage 2. But stage 1, if let's say your school is not participating, or you are not one of because the school can nominate only 5 students per grade. So if you are not in that list, you can also participate independently, for which you have to write one quiz and submit one of the activities. So there you don't have to innovate. You just have to implement the activity which we are going to provide. Stage 2, you will be submitting your own innovation the way it has always happened in the previous years. But this year, because the number of participants is more, you also need to write a quiz other than submitting your innovation.
So you'll give us a quiz.
Yes, and all this communication will happen on the web page as well as the Raman Awards mailing list that we have and the Raman Awards group. WhatsApp
So
group.
if you want to submit an innovation, what is the due date?
The due date for stage 2 is September 15th. Stage 1 is, I think, July 15th or end of July. The exact dates you'll find on the Raman Awards website.
Sir, is this compulsory to join in the competition?
Nothing is compulsory.
Okay.
It wasn't compulsory to attend even this session, but you chose to attend because you wanted to. Same goes for Raman Awards.
Sir, when is the competition and how can we join?
Visit the website. I'm putting the link on the chat.
The video which we have to upload today, sir, do we have to wear a school uniform in that?
No, not required.
Sir?
Sir? Uploading the YouTube link, the
Sir?
Google form link.
The Google form link we will be sharing on the WhatsApp group. So if you are not on the WhatsApp group, please join now.
Excuse me, sir.
Sir, if I'm nominated from my school, it means.
Excuse me, sir.
Yes, then you directly enter stage 2.
Okay, excuse me, sir. Sir, I already have one YouTube video, sir. Could I share it?
Have you already shown the changing of independent variables there?
No, sir, not that. Sir, about experiment means about my new project.
Yeah, so if you think it's worthy enough, you can submit it in stage 2 of Raman Award. But for this assignment, the requirement is that you show changing two independent variables, and the effect of that on the dependent variables should be visible in your video.
Sir?
No, sir, that I'll do it.
Yeah.
Sir, after uploading this video, if YouTube will ask whether can I make it public or linked.
You can keep it unlisted, so it's your choice. It's not necessary for you to make it public, but don't keep it private, because otherwise we cannot access it. So you can either keep it unlisted or make it public.
Okay, sir.
Excuse me, sir.
Yes.
Sir, what all activities we do in this session? Sir, all the activities we should upload it in YouTube only.
You don't have to do all these activities. Do any of, so it can be one of these or it can be your own activity. The purpose of this assignment is for you to experience applying independent dependent control variables understanding on an actual experiment.
Please clarify.
For the Raman, so for the Raman Awards, the activity which we, the innovation for stage 2, is it our own idea or you will give some topic?
Your idea.
Our own, okay.
Yeah.
Only individual or we can make
Sorry, Vishal.
members.
It is individual. Yes, Ashay.
Sorry, Vishal. Just want to let you know it's 12:16 right now.
Yeah, so as Ashay has reminded, we have already exceeded the time allotted for the session. If there are questions, I can take those. If you don't have questions, feel free to leave. We will be meeting again on Monday. So we will be taking break. Sorry. We are meeting tomorrow. After that, we will meet on Monday. So tomorrow, same time, you can join again.
Yes, we